Andy, thanks for having us. Great opportunity. Appreciate the opportunity to come out and talk to you all about Tableau. Really, this is a fantastic community, and I have had so much opportunity to benefit from this community. It's great to be able to come here and share today. So, thank you for everybody that helped put this together. My name is John Tardy. I'm the Director of Analytics at Starr Associates, and myself and Antonio Bayona, who is a senior consultant with our organization, is going to be presenting today on statistical analysis using Tableau. And I know that there is a variety of expertise levels, experience levels with Tableau today. So we're going to hopefully something for everyone. We're going to build out a number of vizzes today, do some calculated fields. I'll talk through a number of different features in Tableau. We'll look at some things that are a little bit more hidden than others, and work through to achieve some results. So as Andy mentioned, we do have some materials. Antonio did post on the LinkedIn group, but this slide here shows you the information to go online and download some workbooks that have the data sets in them. We actually posted it on Antonio's Tableau Public. There's a time on job workbook and a curve check workbook. And I can show you real quick. So if you go to Tableau Public, you know where that is. If you don't know about Tableau Public, great resource. I know Rashid referenced it earlier. One way to do it, you can either go to the link that I'll put up, I'll put it back on the screen again, or you can just search for Antonio. And we're looking for the Tesla man here in space. One of our favorite topics back at work is talking about Tesla and other things going on. And SpaceX. And so there's two workbooks here that are available for download. I'm going to start with time on job, which is going to do some basic statistical analysis and looking at distributions. And then Antonio has a great challenge for you all around curve check bags. So those are there for you. I'm going to go back to the presentation, give you the link again here. And I have just a couple slides here that I'll share. The link is up in the upper right. If you didn't get it yet, you need to download those workbooks. So just before we got started, just wanted to talk a little bit about who we are. As I mentioned, we're with Starr Associates. So we're a boutique management consulting firm, growing quickly, but we do the whole range of management consulting. The foundation of the company is really in the operational excellence space. So we have some CEO is an industrial engineer, Lean Six Sigma type background, and that's really the link for us to the statistical analysis, which is why this was the topic that we chose to present on today. So, as I mentioned, I lead the data analytics practice here, and our data analysts, we're asked to do a number of different kinds of things. Sometimes, yes, we're asked to build a dashboard where there's a particular view or report that the client wants. But many other times, we're engaged in a project team with the process consultants where we're trying to achieve some sort of business objective. Sometimes we get involved in just doing analysis, trying to give them insights into opportunities that exist within the organization, things like reducing expenses, reducing transactions, whatever the goal for that organization might be. And so the statistical analysis comes in very much in play there for us to look at it and try to understand where their opportunity is and give them some insights. So I wanted to just cover a few of the basics of what we're going to be using in Tableau before I get in there. So some things on statistical distributions. I didn't want to assume too much, but some basics. We've got on the right here, I've got a normal distribution. Of course, the mean or average in the middle. But a lot of the work that we're going to do here is also based on standard deviation. And so when we have a normal curve like this, here these sigmas are standard deviations, so 1 standard deviation, 2, and 3. So within plus or minus 2 standard deviation of the mean on a normal distribution, we've got 95% of the population. That's going to be a key fact that we're going to use in the workbook that we're going to build out. Because it helps us to identify potential outliers and to communicate to our business audience statistical significance of a finding. On the left here, I've got a percentile curve. We're going to build one of those out. So basically, this is a running sum of the number of records that we have at each value, presented it as a percent. So this is going from 0 to 100%, and at 50%, we would have 50% of the population below that number, and 50% above that number, and that's the definition of the median. But we can look at other percentiles as well. And then down the bottom is a box and whisker plot, which you may be familiar with. There's one out of the box in Tableau. We'll look at that. And to sort of interpret the box and whisker, the line in the middle is the 50% second quartile median. There's a lower end of the box, which is the first quartile, 25%, third quartile on the upper end of the box, and then we've got these whiskers on the lower and upper end. And Tableau does give us some ability to select some different definitions for the whiskers. That's why I didn't put it on here. One of the definitions is the minimum maximum values, so that's one way we can pick. The other is that they place the whiskers at 1.5 times the interquartile range, which is this QR, and that is defined as the width of this box, essentially, the difference between the third quartile and the second quartile. Anybody have any questions on that before we jump into Tableau and start doing some fun stuff? All right, so let's talk about where we're trying to go. So the data set in that time on job workbook that's posted up on the Tableau Public is, think of it as field service work orders, okay? So we're talking about situations where we have a technician working on a job, they arrive at the job, they complete the job, they were there for a certain amount of time, and we're trying to assess or evaluate the amount of time that they're spending on the job. So a couple different things that we're going to do. This is sort of where we're going to head. We're going to build out each of these business. We have some summary statistics here. We can obviously look at the average. We can look at different percentiles. We can look at the standard deviation. Okay. This view here is a time plot of the average time on job by day. And we're going to do some work to highlight the outliers. This band here is the plus or minus 2 standard deviations that I talked about before. And so we'll get a little bit more into detail about that, but that's what we're trying to build there if you're going to work ahead. We're going to do a histogram of the time on job. We're going to do a box plot. And we're going to do the percentile curve. All right. So let's get going. Okay, so let's look at what we have here in the workbook to get started. A nice tip is this View Data button that we have here in Tableau. And we can just get a quick glance at what's in here. So as I mentioned before, we have an arrival time, so it's a date time. We have a completion time. We have a date. We have a work order number that's just a serial 1, 2, 3. And that's it. Pretty basic. So, well, in order to get started, I mentioned we're doing time on job. So we need to know how much time the technician is spending on each one of these jobs. So we're going to do a quick calculated field. Hit arrival time, create calculated field. Call it time on job. And we'd like to do this in minutes. And Tableau has a function called date diff. And we're going to do that. We're going to get the helpful pop-up to remind me what the parameters are. We're going to do it in minutes. And we want the difference between the arrival time and the completion time. There we go, time on job. So I'm just going to create a new sheet. And actually what I want to do is I'm going to put, I've got these measure names, measure values are always fun. So I want to look at just a little snapshot. We have 42,611 records, and Tableau is now telling me what the total sum of all the time on jobs is. So 7.6 million minutes. But actually, I'm more interested in the average time that we're spending on these jobs than the total. So I'm going to go down to this measure value that we have here, and we can change the measure from sum to average. And so now I got that the average time on job is 180 minutes. So that's a great start. And a lot of times we're asked, well, how much time are we spending on these jobs? So that would be like a really quick answer to run back to the business and tell them we're spending an average of 180 minutes on these jobs. But we like to dig deeper than that, so we're gonna continue further. And one way we can do that is to look at the distribution, because we haven't really looked at what these time on jobs look like yet. All we know is that the average across the entire population is 180. So I'm going to go lots of different ways to do everything in Tableau, of course, but I'm going to select time on job and let Tableau do some work for me. Go to show me, do the histogram. So I already noticed something here, because I've got some values down here low, then nothing, and then I've got some values that are up high. So I'm not really sure what's going on here. Tableau automatically created this dimension for me here, time on job bin, which is defining the width of each of these bins in the histogram, but I can edit it because that's too wide for me. I like to do that in 5-minute increments. Now I actually see that there's two things going on. I still see these values that are up high, but there's also this big spike at 0. So that's not I know that's not valid. We can't have spent 0 time on these jobs. So there's something going on with this data. So I got to take care of that before I continue on with this analysis. So how do we do that? Well, zero's a problem. I don't know what's going on up here. There's a lot of different ways I could get rid of them. I did notice when I glanced at the time here, that it started out, I happened to see that there were some jobs that are arriving at midnight. And I know that we wouldn't be going to these customers' homes at midnight, so there's something else with the data here that I don't like. So that, to me, these are questionable values. So I want to figure out what's happening there. So let's look at another sheet. Let's look at these. Let's look at when we're arriving on these jobs. Do a calculated field, and I'm going to call it hour, and study the hour, the time of day that we're arriving. So for this, we can use date part, because I only want the hour. We want hour. So we're going to look at the hour of the arrival time. And I'm going to change hour to a dimension, because it's not something, it's a number, but it's not something that I want to sum or do any other math on. I just want to know what hour it is. So let's look at hour and how many records. how many records average job. We can create a quick histogram. One of my favorite features, I don't like the histogram this way, going with the hours down. I'd actually like it to go across. One of my favorite features is this swap. So now that's the way I like it. So I see this big spike of records that are at the 0 hour. This is like military time, 24-hour clock. So this is midnight hour, where we have a lot going on. A few that happen really early in the AM here, and then we sort of get into the workday. That seems more normal. So I'm thinking like anything before 6 o'clock, 6 a.m. is questionable. I don't think those are real times. So now I've got these two different conditions that I've identified. I want to select out of this data set before I continue to analyze how much time we're spending on these jobs. So I want to get rid of the anything that was 0 time on job or negative, any number like that that's invalid. And I want to get rid of these arrival times that are before 6 a.m. So we're going to do a quick calculated field for that. So let's go quick calculated field, and we'll call it so if the time on job is less than or equal to 0, or the hour that we calculated so it's less than 6. Any of those conditions. Else, we'll keep it. All right, so let's see what we got. If we go back to our histogram here, let's just put the trim filter on color. We can see that this condition up here did end up in the end up orange. These are the blue is what I want to keep. Oh, yeah. Thank you. Actually, what I'm going to do is this whole. I said time on job less than or equal to 0. They can't spend less than 5 minutes on a job. That doesn't work. So I'm going to call it 5. And that's going to get rid of this whole bar here. Remember, I did 5-minute increments in the on the histogram. So now all that orange I'd like to get rid of, and the blue is actually the distribution that I'd like to keep. And now I can take my trim filter, put on a filter. Keep. Let's go ahead and filter there. Okay, that looks nicer. Now remember, I'm going to just flip back here. Our overall time on job was 180. Average time on job for the overall data set was 180. I also wanted to look at the standard deviation. 366 minutes. So going back to my histogram, the other thing I'd like to do so that I don't have to keep doing this filter, I'd like to apply it. So I'm going to say apply that filter to all the other sheets that are any viz that's using this data source is going to have this filter applied from now on, because I don't want to get tripped up by those exception cases. Do that. And now if I go back to my summary sheet here, you can see that the filter has been applied, and now my average is down to 62. So it's a good thing I didn't go tell anybody that it was 180, right? So 62, that feels better now. Standard deviation is 47. So then we have one view, we've got the histogram. Next thing I'd like to do is look at the percentile. So I'm actually going to duplicate this. And the percentile curve is really like a running total, right? So where the histogram is a frequency chart, because it tells me the vertical axis here is frequency count of the number of the time on job versus time on job. So I want to actually accumulate these frequencies over the times on job. So what I'm going to do is start a table calc. We can do a quick table count running total. So that's already, what we're going for again is, here's my percentile curve, so that's what I'm trying to create now. We got the histogram. We've got the summary, we've got the histogram, now we're looking at the percentile curve. So now I have a running total. Change that to a line. Looks like that. So then the only other thing I need to do is, instead of having this running count as my vertical axis, we want percentage. So we're going to come back to our table calc, edit that. Oops. Edit the table calc. How do I do that? This is a newer version than I had been working on. Show calculation assistance. No, thank you. Okay. But nice to know. Okay. What I actually want to do is add a secondary calculation. And what we can do here is percent of total. So now we've got a running total. So we're accumulating that, and then we're going to do a percent of total as a secondary calculation. And now, if we go back to the viz, we can see it goes from 0 to 100%, which is what we expect, and we can see how that distribution accumulates over the time on job. We can look at any one of these percentiles. In this particular case, we like to look at the 65th percentile. So I'm curious to see what that looks like. So here's the 65th percentile. I can come in here and see that. So the first value that is above 65th would be 65 minutes. So 65 minutes would contain the 65th percentile.
So if you were to convert this to English, somebody, they're not statistically applying you are. How would you explain that in this business?
The curve overall?
Yeah, just the whole piece of the curve overall.
So the curve overall shows me the percent of work orders that that have time on job of a particular value. So everything from 0 to 100. So 100, basically, you can see here. Let's just think. Well, this is showing me that right now my time on job is 50. So 52.89% of the jobs were 50 minutes or less. So sometimes we want to look at something like the average, and sometimes they want other values, depending on what they're going to do with this information, what kind of business decisions they're going to make. As I mentioned, this client, we were interested in the 65th percentile, so, you know, the answer for them here would be 65 minutes. That the 65% of the jobs that occur at or under 65 minutes. We can also, if we wanted to add that percentile to our summary, we can do that too. A couple different ways. So one thing I'll show is that if we drag the time on job measure onto the values here, there is under measures a percentile measure, which is very handy. If we want 50 percentile, 75 percentile, all these are here. So I could do 75, for example. So 75% of all the jobs are done in under 77 minutes. Okay. We don't have 65. So for that, I got to do that a different way. I'm going to do another calculated field just to show how we can do that. So there is a percentile function. Give it the parameter, I tell it what measure I'm looking for the percentile of, and I tell it what percentile I want. So it's like 5. There we go. And let's put that.
If you wanted it to vary, use a parameter.
I could, yep. So here's the 65. So that's the same answer I got on the viz earlier, but now I've got it as a measure I can put in the summary sheet. All right, so we got our histogram, we've got our percentile curve. We want to look at a box plot. Let me just go back to where we're going. So here's my box plot. So, sheet. I'm gonna put, I know I want the box plot up on time on job. You go over here, show me, and here's the box and whisker plot. But it's not allowing me to pick it. Anybody know why? It says 0 or more dimensions. You know, it says 1 or more measures, so on the surface it looks like I've met the criteria.
Then in the bottom it says use at least 1
Or disaggregate, yeah. Yeah, so that's a clue. So the issues right now on my viz here, I have a sum of the time on job, so it's aggregating it. Little feature right here under analysis that I've checked, it says aggregated measures. Uncheck that. You get this interesting look of these are all the values. So we've disaggregated the time on job. Look, it's lit up. So now we can click on box plot, and there it is. And just to kind of remind everyone, remember earlier on I said that I wanted this filter to apply to all anything using this data source. So I kind of forgot about that. So it's a good thing that I put it on there because now it automatically came in. So now my box plot's already filtered to the same parameters that I had built out before. I happen to like my box plot on the side too. So I just want to do it that way. And expand it. There's our box plot. So a couple things I want to talk about the box plot. As I mentioned earlier, so the box itself is showing me the first quartile. So 25% of the values are below, let's see. The lower hinge, 33. The median, or the 50th percentile, is at 52. The upper hinge, or the 75%, is at 77. We had seen that in the summary as well. And we've got the whiskers out here. Remember I mentioned that there's some options around that. Select the box plot correctly, I can edit. Looking at the box plot, and it gives me some options. It says the whiskers extend to, right now it's with the data within 1.5 times the interquartile range. So that was the 1.5 times the range between 75% and 25%. So it's one way of looking at outliers. I could change it to go max. If I do that, just so we'll see what it does, the whiskers now have extended to the min and max. All right. Anybody have any questions? Is that working for anybody that's following along? Oh yeah, okay. So the control chart. So now we want to look, so we've answered questions about, how much time it's taking on the job. One thing we have not looked at yet is what happens over time. Are we seeing any variation of time on job over the course of time of data that we have? So let's take a look at that. And what we want to do here is a couple different ways we could go about it. Let's go, I know I want time on job and I want something with date, so I could just do that. Say, give me a line. I got a point, because it's giving me years, but I don't want years, I want days. Okay. I got a line. But it is showing me, for each day, it's sum of time on jobs. So it's showing me the total of all the jobs for each day. I'd like to look at average. So we're going to change that quickly. Average. All right. Now I've got a plot of the average amount of time that we're spending on these jobs for each day. And I mean, there's some general consistency, but obviously a lot of up and down. So, we get a lot of questions, well, why are we up today? Why is it down today? Whatever it happens to be for that particular business. I don't know, should we care? There's a lot of up and down. So what can we do here to figure out whether the variation that we're seeing is significant or is statistically significant? So one thing we can do is come over and let's look at a couple things. We'll add some references. We'll add an average just so we see what the average is for each day. And let's add a reference. Here we have an opportunity to add a distribution. And one of the options for distribution is standard deviation. So going back to the basics I mentioned before, 95% of the time we would expect the values to be between plus or minus 2 standard deviations of the mean. So we're going to go -2 to +2. So now I got this band. So again, it's telling me that 95% of the time I should expect that we're going to be within this, based on the data that we have here. So we do see some outliers. We do see a few times that we go above that distribution. So those are definitely interesting points. Likely the other ups and downs that are in between here are essentially noise. There's really nothing that we could say statistically. I wouldn't suggest that we're going to chase each one of those up and downs. But the ones that are outliers would be cases for further study. How am I doing?
Good.
I'm good? Okay. So just for a little more fun, because we have Tableau at our disposal here, we could show them this chart, but it'd be even better if we could highlight the data points that we want to call attention to. So let's go ahead and do that. So what we want to do, so here, we'd like to do this. We'd like to get some red dots there on the outliers. And we've talked about the math, so now it's just a matter of how do we do this in Tableau. Well, we're going to do a calculated field, and we're going to do that. Let's go with time on job, create calculated field. We'll create an outlier flag. Think through how we do this. So I'm going to say if. And the thing I'm trying to measure here, the thing I've plotted on this viz is average time on job. So I'm like, hey, this is an average time on job. So I want to build my flag based on average time on job. So here we go, average time on job. Right. If I don't care about the less ones. I only care about if it's greater. So if the average time on job is greater than something, well, I need to compare it to a value that applies for this entire data set, everything that I'm seeing in this window. I've plotted average time on job across here. So this line here that I'm showing, this average line, is the average of the average time on jobs in this window. And Tableau gives me a way to access that. This is the beauty of the Tableau, approach, the visual approach, is it's all based on this viz here. So I'm looking at the viz and I'm trying to discern what it is I want it to do based on what I'm looking at. And so there's something called window average. And window average tells me here, returns the average of the expression within the window. Well, this is my window, my viz window. So I'm going to do window average of what? Well, it's the average of all these points, which was average time on job. So I actually need to go average time on job. And I'm just going to flag I'm missing something. Thank you, teamwork. All right. So just to get this started, because I'm not sure about this whole calculation yet, I'm just going to say, hey, if it's greater than the average, let's flag it. Let's see if we can get that to work. And if we can get that to work, then we can work up to getting to flag that outlier condition of the standard deviation, right? We'll build up. So, all right, so now I got my flag. I am going to, I'd like to do this on a copy of this line. So I'm going to, I'm doing control, click, drag to create a second copy of this average time on job so that I have two of them here. And over here on my my marks panel, I have both copies. So this bottom one is the bottom one that I have here. So I'm going to take my outlier flag and put it on color. That's kind of hard to see. So let's change. I like the red blue. But I want the ones to be red, so I'm going to flip it, and I'm going to I don't want shades, I just want blue or red. So I'm gonna take it down to just 2 steps. So you can start to see now that as the values go above that average line, they're red. It would be clearer if they weren't lines, so we're gonna make that, we're just gonna change the marks to circles. Getting a little clearer now, the red marks are above the line, the blue marks are below the line. And I don't really wanna see those blue marks so much, so I'm also gonna put the outlier flag on size. And now I'm gonna change my sizing. And we can play with it, but now I've got more significant dots in red. This one, I'm gonna go back to the top copy because I don't like giving my color, I want it back to the blue one like that. Alright. So, not quite there yet, right? So, but we've got, this is starting to feel good because we've got red dots above the line and blue dots, little tiny blue dots below the line. But I really wanted it to make the decision based on this 2 standard deviation. So if I go back to my outlier flag and edit that calculation, remember we want two standard deviations over the mean. So I've got the mean, I've got the average, and now I'm going to go plus 2 times, and there is a window standard deviation function. And again, I'm doing this standard deviation on what I've plotted, which is average time on job. Okay, says valid. So we've got, all right. Now the red dots are above the shaded area. And we can bring the 2 things back together by coming up to this measure and doing a dual axis. Thank you. And it looks pretty much aligned, but we can synchronize the axes just to make sure that the values are at the same level. So now we've got the red dots above. Does anybody have any questions?
I mean, that looks great. So is there any interest in the wanting to go along with that?
There could be, that's a great question. In this particular case, I was just gonna focus on the positive ones, but I could change the, I think you can see how I could change that calculated field to flag the ones below. I could either flag it with a different value if I want a different color below. So lots of options, yeah. Yeah, that's a good question. Yeah. That's the distribution, but I have to redo my calculation. But that's the good thing is that you can explore different. If there's no questions, then we'll go on to the next part. I'll have Antonio come up and talk about his check bag challenge.